Hi there, this video is to help recap how to do the mole map. This is the mole map and how it looks to me. If you have a different teacher, it might look a little bit different, but all the same parts are in there. We can go from moles to grams, and then back from moles we can go up to different types of particles. In the chemistry world, we really have, you could say anything for a mole. You could say you have a mole of bananas, then you'd have 6.022 times 10 to the 23rd bananas. But what we're going to be looking at is something like atoms or ions, molecules, or formula units. As a recap, formula units are those things that you'll use if you have an ionic compound. The molecules are anything for a molecular compound or covalent bonds. Ions are anything that are charged particles. So there you go for that. And atoms are things that are neutral elements. And so sometimes if you're going to call something, if you want to know how many atoms they are, but you would actually call it like water would be called a molecule, you got to do this extra step to atoms and ions. One of the problems we talk about today will do that. We're not going to talk about going down into liters on this one, that's using molarity, but we will another day. So here's my first problem. I'm going to take you through this one. How many grams are in 0.0150 moles of CDS? The way I like to start these problems is go question mark grams, because that's my question. How many grams? Question mark grams are equal to 0.0150 mole of CDS. Now, do you have to put CDS in there? No, you don't have to, but it would be a really good idea because then you always know what substance you're talking about. So I would highly encourage you to do so. Now, if I take a look at my problem, this is everything that I need all in one spot. I am starting with moles. This is my starting spot. And it is asking me to get to grams. This is my ending spot. The mole map shows me where I am and where I need to go. It's kind of like a map of a mall. You need to see where you are and where you need to go in order to get to the store you want, or in this case, to the grams we want. It's only going to take us one step, one fraction to do it. So I'm going to multiply it by a fraction, and on the bottom I'm going to put moles. Right now I have moles on top, and I want to get rid of moles, so put moles of CDS on bottom. Same units on top and bottom, they're going to cancel that way. I want to get into grams, so I'll put grams on top, and it's still the same substance, grams of CDS. That's my the whole thing I want to find. In order to go from moles to grams or grams to moles, I need this conversion factor right here, where one mole is equal to that grams on the periodic table. That's when we go to the periodic table and look at the numbers, the average atomic mass, and that's the number of grams for each element according to the periodic table. So if you take a look, you'll see that S is 32.05 and CD is 112.41. So 112.41 is CD, cadmium, and sulfur is 32.065 or 32.05 on our periodic table. And those are the parts I'm going to add up. If I add up those two parts, I get 144.47. So then in my calculator, I'm going to take this 0.0150 times 104.47 divided by 1. That's easy. And I'm going to get 2.16705. Then I got to think about sig figs. According to the sig figs that I have, this is a conversion factor, so it has infinite sig figs. This number right here has 3 sig figs. These beginning zeros do not count as sig figs, they're placeholders. So now I've got 3 multiplied by an infinite sig fig, so my sig figs here are going to be only 3 sig figs. 2.1, not the 6, I'm going to call this 2.17 grams of CDS. Moving to my next one. How many molecules are in this number? I start them out the same. Question mark molecules, that's a big word, so I'm going to write molex. Are in 0.08447 C6H6. Here's where I figure out, I need moles, where I am and where I need to go. I'm starting in moles again, and where I'm going to be ending is up in here. Now here's where I have to decide myself. C6H6, what kind of thing is that? Well, that thing is a molecule, so I would call it molecules. So I can go to molecules in one step. I'm going to do it in one step. Where I put moles on the bottom, moles of C6H6 on the bottom. That way they'll cancel. I want to go to molecules, so I'll put molex of C6H6 on top. And in order to do that, I'll be using this conversion factor, where one mole equals 6.022 times 10 to the 23rd molecules. That's by definition of what a mole is. At this point, I just have to use my calculator properly. Remember this times 10 to the 23rd, you should probably use that EE button. That's the best way. That's the best way to calculate to your, best way to communicate to a calculator what that means. When I put in my calculator, I get 5.0867834 times 10 to the 22. And then I got to think about sig figs. Sig figs for this problem, again, this is a conversion factor, so it has infinite sig figs. This number right here has 4 sig figs. The lower of the two numbers is 4, so I'm going to have 4 sig figs in my answer. 1, 2, 3, 4. I'd call this 5.087 times 10 to the 22 molecules. Going on to the last one, which is going to be a little bit longer. When I look at this problem, it says how many atoms? Question mark, atoms. Of oxygen specifically are in 6.25 times 10 to the negative 3 moles of AlNO3. Whew, that's a lot. So I'm going to figure out where am I, where I need to go. I'm starting in moles. And I want to end as atoms. Atoms of O specifically. Notice I've got 2 spots for atoms here. Because the first thing I have to ask myself, okay, as I move upward, what would I call this compound? This thing right here is called a compound. And it's an ionic compound because it has a metal with it. So I would call it a formula unit. So this box, I have to choose which spot I would call the thing I'm dealing with. The thing I'm dealing with is an ionic compound, so I call it a formula unit. So I can't go straight up here to get to atoms. I'll have to do that extra step to atoms. This is going to take 1, 2 steps. So here I go, my first step. Unfortunately, I've run out of space. I've got to go down here for my first fraction. I've got moles on top. I'm multiplying by this fraction down here. So I've got to put moles on the bottom. Moles of AlNO3, 3. I'm trying to write small. And I'm going to go to formula units. Formula units is a long one, so I'm going to call them faux U's of AlNO3, 3. I know that 1 mole, according to this conversion factor right here, is 6.022 times 10 to the 23rd formula units of AlNO3. Now I'm going to do my second step right here. This is when I'm going to go from formula units, faux U's, to atoms. Atoms. And specifically, this is talking about atoms of oxygen. When we do this part, my hint for that part is to count the number. That's all I can give you here. There's no better conversion factor than that. You have to count the number. So let's look at what that means. If I have 1 faux U, in other words, I have 1 aluminum nitrate, how many oxygens do I really have? Well, I have O3, but that's times by 3. So I have 9 atoms of oxygen. 3 times 3 is 9. For every 1 compound, I have 3 atoms of oxygen. And that'll get me to the end. When I punch those numbers in my calculator, I get 3.387375 times 10 to the 22. Sig fig wise, this right here has infinite sig figs because it's a conversion factor. This is also a conversion factor, and even past that, these are counting numbers, and all counting numbers have infinite sig figs. So again, I got to look at my beginning numbers. This has 3 sig figs, so I'll go for my 3 sig figs, 3.39 times 10 to the 22 atoms of oxygen. Any questions? You can definitely come and ask me. Otherwise, good luck.